Okay, so let's look at the answers to the first problem. So the first question says, name a point that appears to be collinear with EF. Okay, so I'm going to start by finding line EF. I find that it's right here. And I'm looking for the point that's on the same line. So if I take that line and extend it up, I run into point D. So for number 1, the first half of the answer is point D. The second half says which street intersects at that point. So I'm just going to look going across, and I see that it's Travis Street. I'm still getting used to writing on the iPad, so sorry that my handwriting is terrible. But looking at the next question, it says explain why point A is not collinear with BE. And I've covered it up, but BE is this one down here. So looking here, I've run out of space. So looking at the second question, you can see that BE, its line, it's going horizontal straight across here, and A is above it. So point A is never going to intersect the path of that line. So it cannot be collinear with point BE. So I would say this by saying that point A is not on the same line as point B or point E. And this answer might seem really straightforward. You might be going, well, duh. And I hope that you are, because these definitions should feel really straightforward. Finally, looking at problem C. Did I say C? Because I meant to say 3. I might have said 3, I don't remember. But problem C3 says, 2 cyclists start at the same point, but travel along 2 straight streets in different directions. If this continues, how many times will their paths cross again? So let's imagine that they left from C. And let's say that one bike decided to go straight up the street, and this other one decided to go down College. Notice that these lines are going in different directions, and the point where they started is the only place where that line is going to touch. So the answer to number 3 is 0 times. They're never going to interact again.